Hello and a warm welcome back. Today on the bench is the power supply for the Stearns Stereophonic Pre-Amplifier. As you can see, I've already made a bit of progress. I haven't filmed all the fettling. Let's have a look at some of the details, what's going on. So rather than using a dedicated transformer that has a high voltage winding, we're using the old trick. Some of you may know of this, others of you may not, of using two transformers that have a low voltage secondary. So what we have here are two identical transformers, not physically but electrically. So we have 240 volts coming in here. We've got down the bottom here, we've got a double 12 volt secondary, 0 12 volts, 0 12 volts, the same over here. So we put 240 volts in here and we get 12 volts out, which will supply our DC heater supply, and we also get hopefully 240 volts ish out, which should rectify to about 300 volts ish. A lot of those sort of figures are ish, so you know, as long as it's about there, we should do. And then we've got a couple of big high voltage 220 microfarad filter caps in there. They're just sort of flopping about in there at the moment. This is a bridge rectifier for our low voltage heater supply, and the one thing that isn't shown is the rest of the low voltage regulated supply. This was an old, without all this in it, this and a toroid transformer was originally a satellite power supply, and I've repurposed it as I did in the last preamplifier that I built. I've repurposed it to do a different function. So we've got a mains coming in, goes through a switch, got a fuse and all the rest of it. And then originally the toroid had a low voltage winding of about 30 volts, I think, I can't quite remember, and another one of about 28 volts. But basically what I've done, I've repurposed the PCB, which you see here, and just jiggled it about a bit. This is an LM317, and basically with this little pot here and a fixed resistor underneath, I can adjust that so that it then sets the base voltage of a couple of tip what are they, tip 3055s, you know, it's just the old 3N, 2N, is it 2N or 3N, 2055s, you know, series pass transistors. And this is the difficulty. Having built the last one and used these quite a few times, they do obviously dissipate a lot of heat. 12 volt regulated should come out at about 15 volt DC, and so this LM317 has got to dissipate, obviously that it's got to get that to 15 volts and turn it into about 7.2 volts ish, so that it can, you know, set the voltage for these. If you use the LM317 on its own, although it can supply about, depending on which version you got, about 1.5 to 2 amps or 2.2 amps, the problem is that it's got protection circuitry in there, so that if you were to try and use it to power heaters up, sometimes it goes into protection and sometimes it oscillates. And so, having done this quite a few times in the past, I find it's better to use sort of series pass transistors with an LM317. The problem is these dissipate a lot of heat. this chassis here is made of aluminium, and there is another bit that goes on it which is sort of quite a thick plate. This is what I reckon that's about 4mm, really chunky. That sits on the back there, which on its own, yeah, I mean it can handle it, but I found, like, from the preamp that it does get rather toasty. That's, yeah, I don't know. I've not done the actual calculations on the transistors and everything. They'll probably be fine and run for years, but no, I mean we can do better. It's better to try and dissipate the heat somehow. So we've got a few different options. We either use a fan to blow cool air onto those series pass transistors. Say if we were to mount them on the back here, that would help. That would really help cool things down. Or, like I done with the valve tester, just get an external heatsink, bolt it on the back. But the problem with that is, obviously it's not very elegant. A few sort of sharpy bits like and whatnot. Yeah. It's a bit of a tricky bugger. I've got various small fans that could probably do the job, that would fit. Maybe this one is off an old PC CPU which already got a big sort of heat sink on it. Maybe I could bung that on the back, sort of thing. Or the other thing I thought of is to use a couple of these big sort of chunky individual heat sinks, sort of put that in there, sort of with a fan sort of blowing at them. But the problem is room. It's we haven't got a lot. As you can see, I'm struggling, struggling to get in here. I mean, maybe we could sort of do something like that, but then we can't because we've got our output socket thing going there. Where else do we put them? Yeah. So that idea of an internal fan and a couple of heat sinks ain't gonna wash. So the only thing I've really got left to do is to, the only solution is to bung a heat sink on the back. In the meantime, I'm going to concentrate on getting the mains from the switch from our sort of in to our transformers. I've already tested this, they're working fine. That's got to go to the bridge rectifier there, which then goes over to there, and then it's a matter of sorting out the high voltage, the what do you call it, the HTB plus. Bit of progress. The two high voltage HTB plus capacitors are in. Ooh, yeah, fucker. Secure. That wasn't a electric shock, that was just me sticking my fingernail on one of the terminals. That's in. That's all powered up, not powered up, connected to the bridge rectifier. This is the low voltage heater power supply. Still haven't got the series pass transistors in, but we'll get there. Got it connected up to the mains really dodgily as usual, which you can't see off camera. Right, let's power it up and see what we're going to get out of the thing roughly. Right, that's monitoring the HT. Going to bring it up on the variac lamp limiter. Should be about 240 volts mains. Getting 300 volts ish. That's going up over a period of time. Probably because the transformer is sort of struggling to bang all the current into the 220 microfarad capacitors, which I'll get to in a minute. Just knock that off and then put the probes. Okay, I could do that. Obviously shorted something out there. How's beard. And this is the low voltage supply reading straight off the cap. Obviously it's not going through any series pass. Sorry, I'm still sort of reeling from that big bang. Not going through any series pass transistors at the moment, and obviously both of them have got no load. The capacitor is rather beefy, 10,000 mic, which is more than adequate enough to supply 1.5 amps. So everything's working pretty much as expected, apart from foolish people going in and shorting things. There we are the next morning. Got most of the work done on the power supply yesterday, ready to test it. It's just on a couple of resistive loads at the moment. For the heater supply, we've got a 5 ohm resistor, which equates to about 1.5 amps current. And for, oh, go on, squeak you bugger. No, okay. We've got a 12k resistor for the HT load. The Stearns Stereophonic Pre-Amplifier pulls about 30 milliamps, I'm told, from the BOMF. Right, let's have a look. Right, let's try that. Just bringing it up on the variac slowly. The voltages that we get won't be what we get on the actual amplifier. Just a representation, so it's all working. That's the main thing. Obviously we're a bit low, but at the moment it's all sort of temporary and all the rest of it. So that's working more or less as predicted, which is good. So that's a look inside the power that's a look inside the power supply. Just got a 27 ohm resistor tacked in for the CRC filter at the moment, just for the purpose of testing. One thing that I did forget to put in yesterday was fusing for the various supplies. So at the moment we've just got a temporary 1 amp fuse just soldered in there. I just wonder what that was for the HT, because as you heard yesterday I shorted it, so that will save any mishaps like that. Oops. Got the series pass element of the low voltage supply in there, 2-tip 3055s with the heatsink that you can see here. At some point I will do a soak test on it. What's a soak test? Basically you're just leaving it on for quite a long time connected to a load to see how it behaves. Hopefully though that heatsink will be enough to stop those getting too hot, because obviously as transistors get hotter the output voltage will change, it will go up. What else have I done? All right, regarding fusing, we've got a fuse here for the DC fuse. So the AC comes off the 2 transformers, goes into that, and then back into the bridge rectifier. Right, well I think that covers about everything. That's pretty much done. All the major work's done. So now we can move back onto the preamplifier. Well, one thing I didn't mention about the power supply, the only thing left to fit is a crowbar circuit. Because we're using series pass transistors and an LM317, if anything goes wrong there, then the heaters of the EF86s will see 16 volts DC, which is not a good idea. So it's just a very simple, it is obviously a bit missing off here, but yeah, I need to fit a crowbar. Bought some new valve bases the other day, finding some skirted B9 valve bases, new ones, proved to be, well, I mean, obviously I got some, but there were a lot on there. There weren't many to choose from, is what I'm trying to say. There were a lot of used ones, but we're just going to face the same bloody situation, aren't we? So let's find a valve. I mean, I've not tested these yet, and see if they are any better at gripping the valve. There's a EF86. Let's get the orientation right. Oh, you fucker. God, that's a bit too grippy. I can't get the damn things in. Jesus. Fucking Nora. Well, they are ultra grippy. Fucking Nora. Yeah, ultra grippy. One thing I'm going to do though, as two of the EF86s test less than good, I'm going to use a couple of 6BR7s on the output stages, see how they handle it. Right, okay, that's a bit better on the second time. Yeah, but I'm chuffed about those. Step 1, tin all the contacts on the valve base. Step 2, get the tag board out and replace all the wires, because when I replaced this last time I was having to just put little extensions on. This is wax cotton insulation, and it's sticky, but it's probably still insulated, but save pissing about putting little extensions on. I might as well just cut that off, put some new wiring in, bish bash bosh. The other thing is, most of this is solid core wiring. The heater wiring, however, is multi-core. Every time I go to solder it, it gets more damaged, the insulation gets damaged. Although it's a big job, I might just bloody well go in and replace all the heater wiring anyway. We'll see about that one, yeah, because that's a hell of a lot more work. But I've got a hell of a lot of work to do anyway, so c'est la vie. That's the first one done. Didn't take too long at all, but I'd already replaced that valve base. I was worried about the heaters, but if you look at the orientation of this valve base in comparison to this one, it's a little bit more anti-clockwise, as it were, so that the heater wiring, which used to sort of be about here, is now there, and that meant that I could cut off the sort of burned ratty arse bit and reconnect it. Also, the twisting and all that isn't necessary here because it's going to be DC heaters. So let's have a buzzing out, as it were, of all the connections to make sure I haven't screwed up. So somebody's been in and knocked that one and spilled its loveliness. Right, that one, if I remember rightly, should go to HT. No, other way. Ah, right, well, it helps if you turn the meter on. Hell's beard. Right, where are we? 8K2, and hold on, that's 82. Is that 82M? yes, no, 8.2k, which drops the voltage to there, so that should be there, and then that should be our anode. Oh, yes it is, that's correct. Cathode is this one. There's a cathode, but it's also connected to our G3 suppressor grid. What else we got? Cathode, anode, G2 goes to the 8K2. No, that's idiot. 390. There we go. Come on now. Just the leads are tarnished. So that's correct. Our control grid G1, well, we can see where that goes to the wiper here. All correct. Bish bash bosh, job done. Oh, I've got another 4 to do later.